with engineers from Memfault, Embedded Artistry, and Winter Bloom. And I will pass it off to Noah, who is our moderator.
Thanks, Mariah. Hello, everyone. Welcome to today's webinar. My name is Noah Pendleton, and I'll be the moderator for the panel today. Our topic, as you saw on the intro slide, is managing issues and improving products after launch. I'm super excited to hear what our panelists have to say on this subject. They have a ton of great experience to share across like a wide range of industries and like wild products that they've shipped out in the field. So it should be great to hear. To get us started, we'll have the panelists introduce themselves. Thea, can you kick us off?
Absolutely. I'm Thea Flowers, also known as Stargirl on the internet. I am a creative technologist, and I am an open hardware enthusiast and open source enthusiast in general. I build synthesizers and help companies craft incredible developer experiences, including documentation.
Awesome. And over to you, Phil.
Hi, everyone. I'm Philip from Embedded Artistry. I've probably gotten a dozen or more products through the launch phase over my career, and I've supported many more after launch. And yeah, customer service is something I do every day as part of my business for, millions of lines of source code we maintain and the courses we provide for our company.
Awesome. And Tyler, can you introduce yourself?
Yeah, of course. Firmware engineer, co-founder of Memfault, and I worked with Noah at Fitbit, and then before that, Pebble. I was almost always avoiding more of the hardware side of things, but I always came in on the software side and definitely on the supporting side. At Pebble, I think I counted at some point in time, like 40 or 50 updates to the watches out in the field. And so we had our fair share of regressions and issues that we had to debug out in the field. And so like the post-release process is where I spend most of my time.
Awesome. Thanks very much, everyone. All right, yeah, so we're going to be talking today about all these sort of the joy of post product launch and where we fit in as engineering and product development folks. To get us started, we'll have a group question for the panelists to take. So this is our first question. So in terms of a post-launch process, you need to be tracking some key performance indicators, release and qualification, like statistics, that sort of information, emergency bug fix checklist. What kind of things, are top of mind for you guys when you're talking about post-launch, procedures and whatnot?
I guess pre-launch and post-launch, I think the easiest thing for us to track at Pebble and at Fitbit was like, how long would the device actually run before it crashed? When you cut the release, maybe like an hour, maybe a few minutes, or maybe just not at all. And then once you start stabilizing the release, then it lasts a day, then it lasts maybe a couple of days. And I think our bar kind of before release and then after release was that the watch would last about 2 weeks between crashes on average. And that's just across all devices. Of course, you'd like it to never crash, but that was just realistically never really the case. So that was the first KPI I think we were tracking.
And how are you?
Go ahead, sorry.
I was just real quick, how are you gathering that information? Like, did you have like a test fleet of devices?
Yeah, kind of circles. You have all the developers and firmware engineers. That's the watches who would be running the nightly builds because we knew how to restore them whenever they got corrupted or completely broken. And then you had internal employees, and so we had about 200 employees at once, and so they all had a watch, and some of them had two, and that they were wearing. And then it was beta, so like 1,000 basically developers that were really eager to get the new firmwares and didn't really care if the devices worked super well, and then production after that. So continuously trying to get more and more watches and more hours to test things.
I'm sorry, I've cut you off there, Philip. Did you have something you were?
Yeah, I think, related to crashes, metrics that I like to test or I like to track for every build are boot time, right? If your device is crashing, and I think we have a tendency as the system gets developed with more and more features, right? You notice that it takes longer and longer and longer to boot the system to a ready state. And, if you have a crash or your device has to reset, that's something that the user is really going to notice. And so actually tracking that metric and kind of having a target you're trying to hit and making sure you're staying under that target is something that's really valuable in terms of making sure the build is livable. And, you know, battery life is another really important one, right? You just hate to release an update that somehow is, you know, tanking the battery life for the users, and then you don't have a way to gain insight into that until you start getting the complaints rolling in. You know, that's something that you kind of have to track at every step of the way.
Users tend to be fairly vocal about updates that degrade the performance of their device. So.
Yeah. Wow. Battery life. Ooh. Like, so for me, like it's interesting because, you know, I have devices out there that have firmware and devices that don't have firmware. And for the most part, the things that I put out under my name are synthesizers. So for us, it's like not like how long until it crashes. Like we can't have it crash, right? Like if someone's performing a set with one of our synthesizers, if it dies, that's really, really bad, right? And it's so funny that you mentioned boot time, because the synthesizer dies, but can come back up and be in the exact same state and continue like nothing happened. It's just like a guitarist missing a note, right? So as long as we can keep boot time under 1 beat, we're fine, right?
That's pretty fast boot time.
Yeah, well, no embedded Linux going on here, so
Fair enough.
yeah. So that's really funny. So like for me, there's a difference between what it looks like when I'm releasing a new product versus what I'm doing when I'm releasing new firmware for an existing product. Like a new product, like we have to do like serious burn-in testing, right? Like plug in 20 of them and leave them running for 2 weeks and see what happens. If they don't catch on fire, that's great. That's table stakes, but they also still need to make noise, right? They still need to play music. But yeah, yeah, but for firmware updates, it's very similar to what Tyler mentioned, where it's like you take this staged approach, where for us, because our stuff is open source and very community driven, the really enthusiastic members of the community generally are the ones that test their firmware first. And oftentimes it'll be the person that requested the feature or reported the bug, right? It's like, okay, cool, I got you a build, try it out. And it's very important for me when I release products that there is a bootloader in place and a recovery procedure in place so that people can't brick their stuff easily. And if they do corrupt their firmware, it's really easy to restore it. So basically anything that I ship that has firmware has a USB bootloader that is just a mass storage device. So if someone really screws it up, they can restore their firmware. And all the firmware that I create is forward and backwards compatible with any config that's stored on the device. So I'm very careful to make sure that, you know, as I add more configuration values to settings or anything like that, that an old version of the firmware could load that setting so people can revert if they need to.
Yeah, I think that, I mean, that's critical, and it's something that teams tend to overlook, right? Because when you're in pre-production, you kind of get to control the distribution of versions that are actually like in your lab, and they're probably all going to be the same version, your latest development version that you're testing out. But once you release products, you're going to have a population of devices, right? So you need to be able to get information on what versions are actually deployed, what does that curve look like across all of the devices that are deployed. And as I'm, you know, releasing new updates, you need to be sure that like all the possible update combinations might work, which can be a very difficult thing to do, especially as your population grows and the number of versions deployed grow. But it's very easy to forget that 10% of my devices haven't been updated from the initial bootloader. And, you know, along the way, we had a new version, but this latest version is now somehow incompatible with our original version that's still out in the field. And I didn't predict that. And now I've just bricked a bunch of devices somehow. So
yeah. It's
knowing that, having the fallback, so essential.
Yeah, it's especially important when you have backend services to consider your device population, right? Like you can't just change some API that, you know, 10% of your devices depend on because you just broke 10% of your users, right? So it's something to be very careful about, is knowing what your population looks like. And that's really hard, especially if you don't have a device that's internet connected.
Right.
Yeah, especially for us, like musicians, right? Like nobody updates the firmware on their guitar. And it's the same thing with, you know, synthesizers. You know, even though people who play synthesizers tend to be more technically minded, they're still musicians. They don't want to plug in their synthesizer to a computer and update the firmware. That's absurd. So when you tell them to do so, they're like, oh, there's a firmware update. I didn't know. And it's, yeah, so it's like that. It's like there's going to be a lot of devices in the field that are not going to be the latest version. And it's really easy to forget that leading up to launch.
You open the can of worms for me. How are you testing your forward and backwards config compatibility?
So for the firmware
That
side,
sounds
it's just,
like a lofty promise.
from the firmware side, like it's like one of the things that I borrowed from my time at Google was like protocol buffers and how those kind of work. I don't use protocol buffers in firmware specifically unless a client asks for it, but one of the things about protocol buffers is this idea of forward and backwards compatibility.
Mhm.
And it's kind of built into the specification itself. So that's something that like my tests account for, and the tooling that actually generates the code that loads and saves stuff is very specific about is making sure that like you can't just change the type of a field and keep the same name. Fields are only added, fields are never removed, right? Fields can be marked as deprecated, but not actually removed from the structure, so that if new firmware writes the config, an old firmware can still read it. And in the event that like, I need to change the data type of some configuration from like, an integer to a float or something like that, or even just a wider integer or something like that, I just add a new one and try to get the new firmware to write the old one in a compatible way, right? So, or just don't mess with it.
Just deal with it, basically. Got it.
Yeah,
Makes sense.
I think
That's
it leads to like why code bases get so complicated as, we release products and things go on, because, it's really easy for us to change things when there's nothing for us to support. But when we have to start supporting stuff, it's like, deprecating old items and transitioning to new configuration values. It's a lot of work to actually make sure you get to a point where you can safely do that. And often it's easier, like you said, just to not do it and to just create a new thing and let the old thing live on, right? And that is how we get to having so much cruft in our systems in a lot of these cases.
Yeah. The key part is just trying to put all of that complication into one box, right? Like keep it contained into its own little thing. So configuration management, one little thing, right? Don't let the complexity escape. Make your config loader and saver deal with the complexity, and everything else can hopefully live its normal life.
touching on your release process there, Thea. What does it look like the hardware side of things? Like, how are you actually ensuring that your firmware update will work, I guess, when you update it on the hardware, and then maybe even if you hardware revision, like how are you actually going through this release process yourself?
I mean, it's tough, right? Because like my company is 3 people.
Exactly.
Like if you're really generous with how you count how many people are involved, right? And 2 cats. The cats don't have thumbs though, so they're not as useful.
They bash on buttons, right?
Yeah. Lily's really good at inspecting boxes, but not much else. But yeah, it's tough because like, for instance, one of our most popular products, there's several revisions out there, right? There's basically 2 hardware revisions of V1, and there's 2 hardware revisions of V2 out there, more or less. So when I do write and like they have, V1 has a different user interface than V2, basically. It has different knobs. But they run the same firmware. So and there's a lot of reasons for that, but mostly I didn't want to leave any users behind. But yeah, so when I design and develop a new firmware, like I have 2 of each version basically, and I load the firmware up onto all of those, and I run through and test everything. I actually have a script, like a markdown page that says, here's everything to test when you run new firmware. And again, the critical thing is just making sure that I can downgrade to the old firmware without breaking anything. And that, if anything goes super wrong, people can recover it over USB. Like that device in particular, like you wouldn't even plug it into USB for any other reason, other than like changing the settings that aren't visible on the panel. But yeah, like including a USB port was super cheap. So put it on there. People can update their firmware easily. And it's pretty wild. There's this will blow you guys' mind. There's other synthesizers out there where you can update the firmware by playing audio into it. And while that's super cool, that is nowhere near as convenient as plugging in a USB cable.
And dragging and dropping a firmware. Yeah, that sounds
Yeah. Yeah.
I once had a request on the factory line to support software updates via DTMF because it would be faster for the production line to not have to cycle cable connections. And you'd, have less attrition and all that. And yeah, I was just like, is this really the best way to approach it? Is firmware update by touch tone?
Yeah,
So,
I mean, we used to use audio screaming at each other to get on the internet, and there's still viable uses for that apparently.
I think, you really touch on something we haven't talked about much yet, which is having a test plan. I work with a surprising number of companies that, like, when it comes time to release to customers, there's not actually a plan in place for what to test and like what are the critical features that really need to work and how are we going to go about doing that in a repeatable way. And then if that does exist, like so often it's manual when, 90% of the work could be automated, right? And the more you can automate your test plan, ideally by having, unit tests and integration tests that you're building up along the way, the faster you really can qualify releases. And you can make sure that, in the first place, you're only going to invest time in doing this manual release qualification on releases that are good enough to begin with, right? Same with metric collection. You need it to be ideally, automated in the way you can get the metrics and look at these statistics and actually set limits to determine like, well, this build is worth my consideration and the other 10 weren't, right? So that's something that has to be built up along the way. And, it's kind of tricky. Like once you get to the point of launching to do all of that work, you're going to miss details or there's just going to be so much deferred work that you have to go back and do to make that possible that it's often difficult to add in later.
Yeah, I mean, it's like, you mentioned assembly line, like you have to give the people who assemble your stuff instructions, right? It's the same thing for releases, right? You need those same kind of instructions for when you're going to cut a release because you're kind of doing a similar thing, right? So yeah, it's important to do that. And I mean, I'm a big fan of automation, but I work on a lot of things that are small quantity, so it doesn't always make sense to automate everything. But what's more important than automation is documentation.
Mm-hmm.
And in a big way, automation is documentation. It's de facto documentation. But it doesn't always make sense to invest the time in automating something when you're only going to build 500 of this thing. So it makes more sense to be really good at documenting things so that if you do need to automate it later, you know exactly what you need to automate.
One question that I had was sort of along those lines. When you have like an identified issue that somehow like slipped through your test process and there are issues like users affected, it's like midnight when you identified it, and like what do you do ahead of time before you're in that emergency panic mode to like make sure that you can do that sort of emergency bug fix when you need to?
Well, I think
point. Oh, go ahead.
You go ahead, Tyler.
Not just I think to Via's point, always have the ability to update and like always have it be reliable as well. Like, or that's just step one. That's the only thing you can do as the baseline. I love your idea of just the mass USB bootloader that just takes the firmware in. We had an issue at Pebble where we tried every firmware update had to do the actual firmware update itself. And so usually what you do nowadays in modern practice, you have a standard bootloader that you never change that actually does the firmware update, which is so much more reliable and a much better way. We would never do it again. But we broke that system, which was fun to fix. Continue, Phil.
Yeah, I think that, going back to Thea's point, you need to have your processes documented ahead of time because when you're in this emergency situation and it's high stress, that's when you're likely to make even more mistakes, right? And you don't want that to happen. You need to be able to calmly reset, follow the plan, find the issue, address it, release a new update that is going to be good, right? You don't just, oh my God, I got this bug. I need to make this quick change. It's going to fix everything. Then I'm going to release this update. And now I've somehow bricked or hurt or, regressed even more things, right? In my rush to do it. So having your process in place and just being able to follow that is, it's essential, right? Don't panic.
Great advice. The Hitchhiker Guide to the Galaxy has that written on it.
That's right.
Awesome. That was great, guys. I really enjoyed that discussion. So next up, we have an individual question. So Tyler, you're in the hot seat first. And this question is all about like, how do you get the correct debug information or the signal from these, launch devices in customers' hands, making sure you have the right telemetry? How do you plan for the unexpected?
Yeah, it's a good question. The first thing to measure, I still go back to crashing. Like if your devices are crashing, they're not going to be working as expected. But in general, have to have a data path so that you can actually understand what metrics are coming in or if the devices are working. Or you have to have your phone number on the website so that people can call you when their synthesizers are not working as correct or as correctly or something like that. But at least in most of the connected devices in IoT world, some form of a data path back to your system that is outside of your customer support email and phone number, because you don't want to trust your customers. Only the angriest, like 10% or 1% will actually, or happiest 10% or 1% will actually contact you and tell you things are going well or not. And so the most minimal form of data collection from your devices, you don't need to scrape personal information, just like scrape a number or two. And then just to know whether it's working or not. If you're making a smart lock, just count the number of times it successfully unlocks or successfully locks, like literally. And then that can give you a signal as to like whether things are working expectedly or unexpectedly. And then you peel back the onion and try to dig in more. We've talked to so many, I guess, prospects and customers. They will say, our devices never crash. We may not need any sort of like debugging or monitoring remotely. And then we ask them, do you actually know if the devices are crashing? Do you know how many times? And the answer is generally no, or kind of. And then that's like the first thing we just basically like, all right, well, let's at least like get that number for you, or at least help you get that number. And then you peel back the onion. So first thing, I'm curious what Philip and Thea also have done in practice or what they do currently, honestly.
Yeah, I mean, that was great. And I just want to touch on one of your points for like, you gave the example of how many times the lock is actually successfully locking and unlocking. I mean, there's so often that we get to the post-launch stage of a product, and then we're trying to figure out like what to work on next, right? Because we're trying to juggle fixing bugs, and we have these 10 new features, and we've only got so much time. So what are we actually going to work on? Well, if you don't have insight into like what is actually being done with your product, how it's being used, what features are actually being taken advantage of, is really hard to prioritize that work. So trying to get a sense of the parts of the system that are actually exercised most often, and really attending and investing in those is extremely valuable in trying to figure out what work you're going to do.
Make sure to instrument all the most fun or interesting problems so that you can bring it to your product.
There you go. That's the engineer thinking.
Yeah, for me, I don't work with a lot of connected devices. So like my data collection is different, but the idea behind it is the same. It's to be as thorough and get as much of a picture as you can as to what's going on, right? So like if someone emails me and says, this doesn't sound right? That's the kind of bug report I get. I don't get, oh, the device is crashing when I do this, or, someone sent me a text message and it looks really weird. All the characters are messed up. I don't really get bug reports like that. I get bug reports where like, this thing isn't quite, it's not quite as dubstep as I want it to be. And I'm like, all right, well, I need so much more information. But, like, things like tuning issues, or like, I'm giving it a signal and it's not quite doing the thing that I expect. For me, like sometimes the best way to get my information from someone is to just talk to them in real time or listen to what they're trying to describe. A lot of times, like the first thing I'll tell someone when they reach out is, can you send me a video of what it's doing and how you're trying to do it? Because I try not to influence what they're doing to it as much as possible, because I want to see what they're doing. But also like Tyler's thing of like, make sure that you're keeping track of signals that are important. Like, so for us, like recording some events when they happen, even though I'm not going to be able to even look at those events unless someone specifically reaches out to me, is kind of a really useful thing to have, right? Like if there's some kind of catastrophic error, like log that somewhere, right? And on the device itself, and then have a way to retrieve that if someone reaches out to you. And for us, that's USB, right? But we use USB MIDI and Web MIDI to be able to let people edit settings on their devices, but also to help us debug if they're having trouble. So if someone's having trouble with like tuning, for instance, I can have them go to a special web page, and that web page will spit out a running log of what the ADCs actually see from the device. And that helps me debug and figure out if something has gone wonky, or if, things are just completely not working the way they should. So like definitely collect whatever data you can before someone reaches out for support. But when they do reach out to support, make sure that you have the tools and means to gather the information you need to actually figure out what's going wrong and what you could do to fix it.
And often those tools are things that you can develop along the way for your own use, right? Like you're going to need to get debug data off of your devices somehow. So, just consider the fact that you're probably going to want to make this available to customers in some way, even if it's in a more limited configuration than what you might use for internal development, right? Yeah, these tools are essential. You're going to probably build them for yourself anyway, and you need to consider that you're going to want users to be able to access these, at least in debugging scenarios.
Yeah, and it's funny that you mentioned that, because a lot of times like people are like, oh, I need different firmware for running it through testing than production. Like for me, no, it's too much effort.
Yeah.
So all of the routines that we use for calibrating and testing our products are like they're part of the firmware, and they're part of the MIDI spec for the firmware, because you can send special MIDI messages to do system exclusive stuff. So I just leave that in there. So that way, if I need to debug a device, I can send them to a web MIDI page, and you can ask for whatever stuff that we get during factory setup. And if I need to change some setting that we would change during factory setup, I can do that too. Easy peasy. So yeah, I leave all of those tools for figuring out what's going on with the device and programming it and calibrating it on the device. There's no reason for me to remove them.
Yeah, I think we're going to see more of that as right to repair comes into play, right? We're going to need to provide users with ways to diagnose more things themselves and figure out if a repair or a modification was successful on their end without, needing special images and all of that. So I expect to see more of that kind of thing happening.
It's funny, the
outsourcing support.
One way to bring costs down.
I super love the notion of like the web-based tools, like Web USB, Web Serial, Web MIDI. I think is super. They're relatively recent, I guess, last couple of years, but super powerful. And I've been loving like any of these little niche companies like have been using them, and it's really cool.
Yeah, Bluetooth is also super cool for that, because there's so much you can do with just having some connection to the device and being able to pull data off of it. There's a lot that you can do over that channel.
Awesome. Yeah, and Philip, you had mentioned something about like user self-diagnosis. It's funny, we've had like the vehicle onboard diagnostic, like OBD standards for automotive, has been around a long time. You like go to your auto parts store and they'll read off the codes for you. You can buy a cheap reader yourself, but we don't really see a lot of that like self-diagnosis stuff in like IoT devices. They tend to be a little even more constrained than automotive devices, which is kind of interesting. But I'm hoping in the future we can get more and more of that.
Because they don't buy a big enough flash part to store the code. So yeah. Now I'll step on my pedestal real quick. Buy 2x the amount of code space you think you need.
Oh, such good advice. So we have another individual question this time for you, Phil. This one's a little broad, but it's all about how do you minimize support costs post-launch in terms of like, actual dollar costs, but as engineering time is critical in that phase of the product too.
Yeah, I mean, I think we could have a whole panel discussion dedicated to just that one topic. But if you're looking to minimize support costs, I really do think it helps to go back to the fundamentals. There's a lot we can learn from Dr. Deming's work, such as quality saves money for the company And when we're looking to optimize cost, we really need to look at total cost over the system's lifetime and not just, really optimize for some short-term objective. For instance, saving 7% on the flash part instead of, paying 7% more and having the headroom that you need to develop more features and do all the stuff you want to do, right? That's a short-term optimization that really hurts you in the long term. The if we don't put defects into the product to begin with, if we start with a design that is actually reliable and maintainable, if we're focused on continual improvement, and every time we see an issue, we're taking some corrective action, we're documenting some step, right? We're moving our processes and our system forward in some way, you're going to have less rework, less repair, less customer facing problems. And that's what's going to drive your support costs down, right? What you should be aiming at is you actually pay zero for support because you built the product that does everything the users want. It's infinitely reliable. It never breaks down and you have no defects, right? That's really where your site should be set for optimizing support costs. It's not really achievable because, we're constrained and we live in physical reality, but where you aim really does have a big impact on where you end up. And, I think collectively, what I notice is that we have a culture of aiming at getting to launch as quickly as possible. And we're going to take every shortcut we can along the way to make that happen, right? We're going to rack up technical debt. We're going to skip documentation because it's a waste of time. We can't invest in automation because we need to work on features instead. Oh, these capabilities are definitely essential, but they're not critical enough to make it on the pre-launch list, right? So we take a lot of these shortcuts, but the reality is that, okay, you're going to spend, I don't know, 1-2 years, maybe more, maybe less, getting your product to launch. And then if you're successful, guess what? You're going to be supporting and building on that initial work for another 5 to 50 years. And in my experience, it tends to be on the longer end of that range. So, we kind of just need to acknowledge that this long period of support and improvement and, iterating on the products exists, and realize that when we're, taking this critical initial development period and making all these shortcuts, we're really just kind of building a really shoddy foundation for support, right? We're making it harder when it comes time post-launch to iterate, to, fix the bugs that are there, to develop new features. And we're really deferring a lot of work to a time when, we're not going to have so much space to get it right. You have more obligations when you're selling the product and when people are using it, because you need to keep the factory line running. You need to qualify new components because another one reached end of life. You're fixing the bugs that your customers are seeing. You don't actually have all this time to go back and clean up your mess in the way that you thought you would. So trying to build something right, is a really critical step in minimizing those costs. And I think, an easy way to is to incorporate this is like a lot of the stuff that we need to do. I'll use the software side as an easy example, right? We need some kind of debugging infrastructure. We need to be able to monitor our devices. We need to be able to, ideally stop ourselves from putting defects in. So before you start development, set up your CI server, incorporate some kind of test suite, put in static analysis tools to catch issues. Do it when it's easy, when there's like no code in the system that you have to, bring under control. And it's not like this stuff takes a lot of time to do anymore, right? Like I have project skeletons that I maintain that are open source that, out of the box, you start with integration for all the tools you need. It's CI ready. Memfault is like a one-stop shop for, debugging and metric collection and fleet management with stage rollouts and firmware updates and all of that taken care of, right? So you can often do a lot of this work in less than a week, in less than 2 weeks, right? But we often leave it until the end, and then it's so much harder to, get that to happen.
Yeah, it requires a lot of like diligence on the product team. I've seen it like be quite a challenge. You're at that last month stretch, and you realize you hadn't up front of the project like made sure that like we had an OTA test plan before we ship this thing. Like it can be pretty demoralizing even when you're ticking things off the list. Like, well, I guess we're not gonna test calibration or something.
Right.
And yeah, folks like you have been through the ringer a lot, are super valuable at that stage of a product when they can say, here are the things we absolutely need, right?
I wish I could, get people to do it in the different order. I think that's really the challenge is no matter how many times I say that, I do end up seeing like the number one shipping delay is, we didn't actually implement OTA updates, and now we want to ship in a month, but we can't because we didn't do the work. And turns out that's, 3-6 months at least of effort, right? Whereas up front, you could have kind of incrementally done that every step of the way, and it would have been much easier.
You need to go through the pain once or twice, I think,
Absolutely.
to go through the other end and realize that there are better ways to do it. Go ahead. Yeah.
Go for it, Tyler.
The short realization I had here is like the first thing we do as engineers is like write code and be able to compile and retest it very quickly, and also be able to just see a log very quickly. And then that's also the last thing we think about, like when we're going to production oftentimes, is like, I don't need logs and I don't need to update this. It's actually kind of wild to me, but it's like literally the opposite of I've worked at companies that don't think about OTA and don't think about logging in production at all. So
yeah. And I think like, what's the fun work? I'm an engineer who likes to play with electronics, so I'm going to start playing with electronics, right? Or you're an early stage startup, you got all this investor money. How do you get more investor money? Having demos, right? So there's reasons that we kind of tend to go in this way, but that's not the approach to take if you want to build a successful product and like you envision your company being in existence 5 years from now. You have totally different concerns if that's the case. And, I think it, like you said, it takes going through it and feeling the pain to realize that, oh, if I do this at the very end, right before launch, I don't actually have time to do it well. And there's a whole lot of things I would have done differently along the way, or like problems that could have been fixed if I had actually done this earlier, right? It's hard to make a product repairable if somebody's telling you 3 weeks before launch that, hey, that we can't actually repair this product at all, right? Because I have to destroy half the product to swap this one part out. That's something that you can fix when somebody's telling you that at a proto build or a EVT build, but by the time your product's in a warehouse ready to send it out, it's like way too late. So there's a lot of reasons you want to get that feedback earlier, be able to incorporate it into your system as you're working, and it's going to be easier to support your system and achieve these things, post launch.
Yeah. What really cooked my noodle about what you just discussed was when you mentioned that, like, in the ideal case, there's no support because we built the perfect product, right? Like, that never even occurred to me, because with something as subjective as a musical instrument, that's never going to happen, right? There's no such thing as the perfect guitar or the perfect synthesizer. And even if there was, no one would be interested in it, because the only objectively bad instrument is one that doesn't work at all. Because every like weirdness, everything that is kind of wonky about an instrument, people will grow to love, right? Like there's weirdness about vintage synthesizers that don't really perform their job very well that people love. And if you try to fix that, they're gonna be like, this sounds soulless. It's that sort of thing. So that's a really interesting thing that I never really considered in the music technology space, where it's like, even if I release something that could be considered perfect, there's going to be someone out there that's going to have a problem with it. And even if everyone loves it, people are going to want to do so many different things with it that there's going to have to be some kind of support, some kind of discussion, some kind of interaction with the people who are actually using what I put out there. So that was interesting. Yeah, thank you for that one. That one cooked my noodle.
Well, I think that might be a special property of music or other performative things, whereas like, I don't want my Kindle behaving in a unique way.
Yeah, no, 100%. And that's the thing, is like it's subjective, but like you do want, like units of the same kind of synthesizer to sound the same, to work the same. But the experience of the individual person using it is going to be different. So it's very weird. It's like if you had a Kindle and everyone saw different words on it. It's very strange.
Yeah, that's so cool. And of course, all these different industries that these devices exist in are going to be super different. So yeah, user expectations for a gas valve are going to be different than something that's like a smartwatch or something like that. Really cool insights. So for you, Thea, we have this question. Because your products are like very hardware centric and people interact with them like in a very physical way, what kind of things do you do to prep for like hardware support? We talked about it a little bit, but just, if you have any other thoughts on that.
Yeah. Yeah, building a product that people physically interact with is hard. Beyond just a touch screen, like software is so much easier because yeah, you have a mouse or a touch screen and that's your interface to the world, and that's something you have to worry about. For us, it's like, okay, we have all these electromechanical parts. We have knobs and switches and potentiometers and all kinds of other things that could go wrong and be weird. So, what do we do to make sure that we're not constantly having to repair instruments that have messed up stuff? And it goes back to what Phil said, where it's like, don't cheap out. Don't pay, 20% less for an electromechanical part when you could spend 20% more and have something that's much, much more reliable. So reliability is a big thing for us. Like I am very picky about the components that go into our stuff because I don't want to endlessly field support requests and repair requests. So it's, and I'm also in music tech where prices are a little higher. The expectation of price is higher, so people are more willing to pay for a premium product rather than just trying to buy the cheapest thing that does the job. I mean, there is a place for inexpensive music instruments, for sure, but in general, like our whole thing is being made as close to home as possible. So a lot of that is also sourcing components that are high quality. So yeah, that's a big thing, right? Reliability. The other thing is that all of our designs are open source, and I also publish, the manufacturer part numbers for everything that we put on a module. So if people need to do repairs themselves, they can. Or if they can't, they probably know somebody who can, or I can connect them with another user in their region that can help them do it, right? And that's a big thing as well. It's like, with this stuff, it's not just, oh, I need to update the firmware to fix a bug. Sometimes people just have a bad potentiometer or a bad jack or, something like that. And it's like, well, that just needs to be replaced. And rather than just scrap the whole instrument, let's see if we can get someone to replace it instead.
That's amazing. That's truly the power of open source hardware. I think you see online occasionally folks are like rebuilding some old ThinkPad or something like that, and they've managed to scrape together some data sheet or schematic, off the internet. But when things start out in the public domain, it's so much easier, right? You can sort of have this lifespan of repairability on these devices. Yeah,
for sure. I mean, it's the same thing with like a guitar, right? Like you're not gonna throw out your guitar every time the strings are dull, right? Like you're just gonna replace the strings, or if one of your pickups dies, we'll just replace the pickup or take it to a technician and have them replace it. Like I really am all about this should be repaired, not replaced, not scrapped. And with synthesizers, vintage ones have very much taken that approach, but a lot of modern ones feel very much designed to just be thrown away. And I don't like that. I want the stuff that I make to be able to be repaired and worked on and iterated on and improved on by people who aren't me, because I simply don't have the time for it.
I was actually going to ask you if you've had a customer like fix a hardware or even a software bug for you. Like, are they building a firmware every now and then and being like, oh, you have this memory leak, or hey, you have this?
Yeah, absolutely. All the time. Yeah, 100%. One of the things that is super, I think, just one of the things I'm proud of that I've built is that I don't develop new products or updates to products in private and then just release them all at once. There are some open hardware companies that do that. I'm not that person. I have a group of people who are on Discord, and they are enthusiastic and knowledgeable and helpful. And not only do they help each other and other users, but when I'm developing something, when I'm working on something, they're giving me feedback. They're like this trusted group of people that I can, you know, like rely on and, you know, trust to give me good feedback on what I'm building. And like that is so important. And it's something that you don't get if you're doing closed source stuff, right? Because it's like, if you want someone else's opinion, you pay a contractor, or you hire, you know, you hire somebody else or something like that. And that's a whole thing. And DAs have to be signed, right? Like, but yeah, no, like, and I encourage people in my community to do stuff, to add features. I mean, for example, one of our synthesizer modules, someone added the feature for it to quantize notes to a specific scale. So if you're not a musician, that probably sounds absolutely nuts. But basically, like, it makes sure that you're always playing in the right key. And we didn't have that to begin with because, you know, no one really asked for it to begin with, but there was one user who wanted it. And, you know, I told her, I'll consider it in the future, but if you want to write it yourself, here's the code. And she did. And it's in our firmware now. So yeah, she added it and it's in there. So yeah, like, people add features,
cool.
people fix bugs, you know, all kinds of cool stuff.
Super cool.
That is awesome. We talked a little bit about like repairability of hardware components and that sort of thing. The other sort of side of that is like, and you just talked about, like, you know, users servicing their own software, but are there other things? There are, you know, cases where it's not really practical or possible to do like an open source like, you know, firmware for your users to be accessing and modifying and whatnot. Are there other things we can do in those cases to provide users like some way to help themselves, or at least provide more information to us?
I have thoughts, but I would love to hear from Phil and Tyler first.
It's about the Memfault product itself. So like a small module of code. The one thing I was excited that just landed yesterday in our SDK was like a self-test. Like, even for developers adding Memfault to their own products, we now have like V1 of a self-test. You can just run test and it will make sure that your core dump storage is set up, that your metrics are set up, and that you can do a couple of other things. And I thought that was a really good idea. I would have loved to have a thing of Pebble that was just like, find a way to do a self-test. We actually baked it into the firmware, but it was totally hidden from users. But like, I don't know, just do a hardware test and you can tell us if your flash part's bad.
Mm-hmm.
We don't have to like figure that out ourselves. That would have been super nice.
I'll defer to you. I would echo just what Tyler said. I think both of those are very good ideas.
I mean, oh man, there's so much, right? Like, I mean, looking at what iFixit is doing just in general is just a huge thing for the right to repair. And it really comes down to empowering users to fix their own stuff, or to have the resources to get someone else to fix their stuff, right? And you know, we see this with like, it's funny that you mentioned like car diagnostics earlier, right? Because that system existed so that, you know, people could diagnose their car, and independent service technicians could diagnose a car and figure out exactly what to do. So yeah, self-tests, service manuals, like, there's a lot of that stuff that can be freely available, if not open source. And, you know, having tools like a friendly little web thing that you pull up and you can connect your device to it and it can tell you what your device is thinking. You know, like, any of that stuff, making replacement parts available. Like, there's so much, and there's so many interesting things that are happening out there that are both open source and not open source. But I mean, I think that if Apple can start making self-repair kits, despite there's a lot of criticisms I have of their self-repair kits, but the fact that they can start going in that direction, even a little bit, means that anybody can. Because I mean, you think about something like an iPhone or an iPad, it's one of the most unrepairable things, right? Like, it's very hard for you to repair yourself. But there is a lot that users can do themselves. And I actually started my career as an Apple tech, and I've seen all the service manuals that require you to, sign all kinds of paperwork saying that you won't share it with anyone. And there's no reason why those should be hidden away from people. There's nothing in there that any of Apple's competitors would not be able to determine themselves, right? There's no secret knowledge in there that should be hidden away from the public. So, just food for thought is to make it easy to understand what is going on with the device and what might be going wrong. Make it easier for people to get the tools and resources and parts necessary to repair something. And yeah, make it easier for them to get in touch with each other so that they can help diagnose problems together. The less that you have to be in the loop, the better it is, not only for you, but for everyone. Because the last thing that I want is to own a physical product where there is only one company in the world that holds the secret to keeping that product working. So yeah, the more people that know the secret knowledge, the better.
And we've seen so many instances in the past few years of like, great, we bought this cool IoT device that does all the stuff we wanted, and now that company went out of business or they're not interested in supporting it anymore. And so I just have this brick, right? That's not really a situation that anyone wants when they buy.
Infuriating. Yeah. Like, honestly, like, even if you are going to go closed source all the way, the day you go under, just publish everything. Just do it. Like, on your way out the door, just upload it all to Google Drive or something. Like, come on. Or an FTP server if you want to be old school. Like, because then people can at least, like, very motivated people can at least go and figure stuff out.
And we've seen that there almost always are very motivated people who are going to try to do what they can to keep a product alive. Like if they use it, if their house, it totally incorporates this product everywhere, right? There's a set of motivated people who are going to try.
Yeah, and even just like it could be repurposed. An interesting one is Spotify had this thing called the car thing for a while. It was a little device with a big knob on it that mounted onto your dash and let you play Spotify tracks, through your car radio and stuff like that. It was really nice, a very small device, very cute. It runs like a very stripped down version of Android. And like Spotify had like a huge sale trying to just get rid of units because they were basically going to stop supporting it. And so a bunch of hackers bought it up and started reverse engineering it and stuff like that. And like, it's amazing what they've done with it, but it would have been so much easier if Spotify just published the SDK, right? And I really wish they would have, because if they had released it, they would have sold even more of these units that they didn't want, right? Because there would have been more hackers that wanted them. But people have been repurposing them for all kinds of things, like 3D printer displays and all kinds of cool stuff. So it's just that sort of stuff can give your product not only a life after you've gone, but also it can give a product a different use in it while you're still supporting it, right? Like there's so many possibilities that are hidden behind like this sort of walled garden approach that people have been taking to hardware.
Some idea that is not quite connected to what you said just now, but goes back to your earlier comments on just making, documentation and code and things like that available. I think one of the things that will make right to repair more difficult is there are things that happen in a factory when I'm building a product, like calibration. If I'm building a camera, my camera gets calibrated for, making sure the colors are displayed consistently, that there's the expected white balance levels and there are correction factors applied. And I think one challenge that we're going to have to figure out how to overcome, because, right to repair regulation is coming for us. It's something that we need to start thinking about, is how do our manufacturing processes and, our supporting systems and our documentation need to change to account for that, right? Like, I can't just now say, okay, you can replace your camera module because you cracked the lens stack and now your camera doesn't perform the way you expected because you don't have an image lab at your house and you don't know anybody who has an image lab, right, to do the calibration that's needed. And that probably means that if you want to support that, you need to figure out how to calibrate modules and how to store that calibration data on a server. And your software needs to be able to say, oh, this is a new camera module. I'm going to go to the server and fetch the calibration data for that somehow, right? There is, there are changes that can be done to make these repairs and the self-service easier, but it is also going to take some rethinking of like how we approach these problems when we're building products in the first place.
Yeah, absolutely. It's funny that you mentioned that, because like all of the factory test and setup scripts for my products are open source. So people can go and look at them. Even if they don't have the specialized equipment to run them, they can still go and look at them and see what we're doing. That's step one. Like, like let people know like what it is that you're doing to calibrate and test these things. They may not have access to the 6.5 digit multimeter that is, scripted and automated so that I can measure DAC performance, right? But it's, it's there. They understand how it's validated. And I think that's an important first step. And if you give people that stuff, sometimes people will just figure out a different way to do it that maybe doesn't require all of that. And maybe they can't get it up to quite the perfection level that you have in your factory. But if it's the difference between that and something never working again, the compromise of you can kind of get it calibrated using this method is way better than the alternative of it never working again, right?
Totally agree with you.
That's awesome. Love that. Love that. We're getting close to the top of the hour. We have a few audience questions, but before we dive into those, I'm going to just share the contact information for our panelists. So, yep, here are today's panelists. I want to thank all the audience members who came in and watched us chat about this awesome stuff. And thank you so much to our panelists for all their great insights today. And this information will also be in the follow-up email, so you'll be able to access all their socials and whatnot. All right, diving into a couple of the audience questions. The first one we have is, what are the best practices of getting backward compatibility for configuration and calibration data into the firmware design in context of a device that is factory calibrated but can be firmware updated in the field?
Yeah, I mean, for me, like I store calibration and settings, like user settings, in completely different parts of the flash or whatever, so that those can be evolved independently. And like there are instances where I've released new versions of firmware that now have more calibration data than the old one did, right? And it's just, it's that same philosophy of don't delete fields, add new fields. If you read an old one that doesn't have the new fields, pick a good value for it for default, and then keep going, or try to convert the old value to the new one. Like it's really setting yourself up for success in that, which is where you make sure from the beginning that you have set up your unit tests, the way that you define your data model in a way that makes sure that you're not just able to remove a field without something throwing up a red flag, right? So and our test suites, we have like a little binary blobs that are each version of the settings and each version of the calibrations, and we make sure we can load them and save them. So yeah,
including the version number, essential, easily overlooked, because you can read the version of that configuration data area or the calibration data area, and you can understand how to correctly interpret it, or you could even perform a migration if you don't want to leave all these old values around, and you have the ability to make sure your fleet of devices is going to stay up to date with versions. Like if I can see it's an old version, I'm a new version, I've got baked into the firmware the proper process for doing the migration, right? That now becomes achievable.
Yeah, no, that's super important. It's one thing that again Protobuf does really well, which is it has versions as part of baked into the IDL. Mm-hmm. But if you're not using Protobufs or whatever, yeah, have a version field. It's the first field that you should add is version.
Version your APIs, especially for remote services. You can provide 100%. Different endpoints depending on the version. There are a lot of ways, but you need a version, right, to be able to manage things appropriately.
Yeah. And it's funny that you mentioned web services endpoints having different API versions. That's the exact same mindset, the exact same approach that you should take to configuration and calibration data, where you still have the old handlers, you still have the old version that's working. It's same thing with configuration. You're just hitting a different API endpoint, basically.
Yeah, those are great strategies. One thing we used at Fitbit when we had to do several migrations of old user configuration data, we would have like each migrator would run in sequence, right? So if you had to go from if a user updated from a very old firmware version and didn't skipped intermediate hops, we had to make sure we handled that case as well. And you'd mentioned like testing a ton of different like migration paths. Like basically, if you can cover all the ones in your field of devices, that's probably the ideal case. So, and automating it. I wish we had that at Fitbit because that would have been really nice. But we did think by hand, and it was okay.
But for something
It
like
takes
that,
so
I
long
feel
to
like,
test that by hand.
yeah, I feel like the time you took to test it by hand twice probably would have justified the automation for doing like, let me flash these devices with all these different versions and then try the update. Like,
Mhm.
that kind of thing gets pretty complex pretty quickly.
Yeah. Yeah. And the good news is a lot of the complexity there can be solved up front. And then as you go on, releasing new version, you'll pay dividends on that as you go.
Yeah, that goes back to that point I was making where it's like you got to look at the total cost of doing something, right? And so often we do the easy thing now, but it's just going to make our work harder and harder and harder down the line, and that's not the way we want to do it.
Don't set your future self up for failure.
Right.
Another question we had come in from the audience was, what do you do for anticipating disaster recovery for devices that are only wirelessly connected? So there's no user input, maybe no user accessible, like recovery ports.
I guess a couple
Having-
things we can touch on. Oh, go ahead, Philip.
You're the man. Go, Tyler.
Not. Anyways, I'll keep it short then. I'll keep it short. I really like the idea of web Bluetooth because you have one interface and probably one type of computer that you can access, and they have a better Bluetooth suite than probably all of us. And so as long as you work with web Bluetooth, that's one way to do it, or like one sort of, the common wireless standard. Second, and this is the learning that I mentioned before at Pebble, like have the recovery firmware have the wireless stack and have that be stable and never changing for the most part. Or only change if a future version of the iPhone broke your firmware update or broke that wireless capability. But have it, we of course, with every firmware update at Pebble, we changed the Bluetooth stack, and we probably broke firmware update or some sort of wireless connectivity with every single firmware update, which was a pain. But if we had kept that recovery firmware stable with the wireless stack, we would have been in a much better place, and we would have known it almost always works. There's no issue with it.
Yeah, I mean, that's a tough question. Like for me, I would be like, never design a product that cannot be plugged in via USB. Like, just don't do that. USB is so cheap. Just like, like even devices that don't actually have a USB thing on them can mostly emulate like low speed USB enough to recover from bad firmware. You can bit bang low speed USB. I promise you can. And USB ports are cheap. And if you're worried about like, waterproofing or something like that, well, hide it. Make it hard to get to. Make it they have to crack the device open. It's better for them to have to crack the device open and plug in a USB port than for them to have to send the thing to, a dump or send it all the way back to you and waste everyone's time in the process, right? But I also like the idea of making sure the bootloader or recovery firmware has Bluetooth or something, some stack that is frozen and it's going to work, and just let it work, Or if your device has a speaker and a microphone, you can just have users play back. Yeah, you can have users recover firmware by having their phone scream at it for a few minutes.
I need that in a blog post. I'll ask you later for firmware update via audio. Like what are the tools you need to encode on both sides to make that work?
I would happily send you resources for that.
I'm sure you have some references to it. So
coming up in the Memfault SDK.
Yeah, so many IoT devices have microphones. Yeah, if you have a microphone but you don't want to put a USB port in there, write your firmware so that you can update the device by screaming at it.
That's great. I love that. One other point, when Tyler was talking about like a recovery firmware image, make sure that you have a way to, if the device is like boot looping, to get it like automatically get into that recovery mode. Because especially with like a sealed device that's like unable to like push a button to put it in a reset or whatever. Yeah, just wanted to mention that because I've been in there before.
And tying that back to like crash detection as being an essential thing, that's a great way. If you are crashing a certain number of times before you boot successfully, or crashing a certain number of times a day, revert to the previous firmware, revert to the recovery firmware. That's definitely essential. And have a command where you can remotely roll back firmware, right? Don't just allow only forward updates, right? That's another problem.
Yeah.
That I often see people run into, is like, we can only move forward, which is going to make a lot of this work we're doing now harder.
Yeah, and make sure that crash detection is in the bootloader as well as the regular firmware. Because it does,
For reasons mentioned.
yeah. A lot of people forget that. It's like, yeah, your app can detect if it crashed, but what if it crashes so soon that it has no idea? So yeah, let the bootloader figure that out.
And it's like there's a build on every project I've worked on where that happens. Like, we're crashing before we even get to main. Great.
Yep. Yeah, you messed up something in the linker file or something, and now nothing is working right. Yeah. Or you just had a bad firmware flash, and the first segment's messed up. So yeah, your bootloader should be able to figure that out.
If we're going to keep saying short best practices, factory reset. We had V1 of factory reset, which kind of just like assumed the file system worked and assumed a few other things worked. V2 of factory reset was just like hard clear the flash and basically get it back to like actually true factory state, rather than just like scrub a little bit with a wet mop. It was like actually like burn the whole thing down and then assume that the watch is completely fresh. That was like the better way to do factory reset.
Absolutely.
And all of this requires buying enough flash up front. Okay, you can't do this if you shrunk your flash down and none of this fits, right? You should have bought more flash, right? So definitely one of those things to not optimize too early.
Yeah.
Add extra flash overhead.
We just had one last question come in. We're a little over the hour, so we'll make this our last one. If you are, another topic or another question on the recovery mode. If you have a stable bootloader, but you've written corrupted firmware, how are you going to get back to that like recovery state if you have like bad firmware already copied in?
Yeah, I mean, most devices make it where you cannot overwrite the bootloader unless you do a very, very specific set of sequences. So in general, you should be using a device that either has a bootloader ROM that cannot be overwritten at all, or it has a protected region of flash that can be overwritten. So yeah, that's your first step. Don't cheap out on a device to the extent that it has no way of protecting its boot ROM.
And there's other strategies like around like AB, like making sure, and MCU boot has support for this. And I think there's a couple of articles that talk about strategies here, but things where even if you get a corrupted like state, there's always like a healthy partition you can swap back in.
Yeah,
but you need enough flash.
You need enough flash. Yeah. I mean, and for bigger devices that are running Linux, like Chrome OS does this, right? Where it has the AB switching stuff. So yeah. If your device is complicated enough to run Linux, it's probably complicated enough to have AB firmware set up. So
folks are gonna thinking we're shilling for big flash company, but we just have been there. More flash is better.
I feel like most product heroics I performed are related to not having enough memory. So
we have so much memory to work with these days, guys. Like, yeah, don't cheap out on it.
People like to work hard, not smart.
All right, I think that does it for open questions.